So it really is something that should be looked at as sort of an accelerant more than anything that could be throttling the growth and adoption of these models.
The extent that we can actually start to build AI systems in the future which do have a better connection to the real world, and that's not a 0-1 thing. It's, there can be degrees of integration with the real world, will help make these AI systems have more common sense, more abilities, and also probably have better alignment to human values.
Data representation is going to be a key area that's going to unlock a lot of the capabilities in terms of differentiating and gaining a competitive advantage.
Can we create a shared mental representation between the human and the AI system?
Next slide is really trying to show the sorts of components or obstacles that need to be solved, or ingredients that need to be achieved before we might achieve general intelligence. The big one that people often are thinking about, because ChatGPT doesn't do it, is reasoning, and actually the kind of reasoning that we humans think of as reasoning, rather than synthesized pretense of reasoning. But it's quite a lot here in terms of what is necessary. I want to draw out the things that ring-fence these, and that is the need to accelerate the power of the hardware, and it's described in the AI world as compute power or compute. And also the point that we all need to start to develop these curation skills, and that's probably going to be touching all of us in some shape or form, in order to bring AI to a position where it's useful to us.
I think an interesting way to look at the role of compute as far as like the evolution of AI technology is to maybe contrast it with some other technology evolutions that we've seen in our lifetimes. Like the one I like to point to is the internet revolution. All of us here lived through that. And really the fascinating thing here, and I think it's probably more profound here in the United States, because one of the things that slowed down the adoption of the internet and didn't get us to Web 2.0 as quickly as maybe we thought was literally having to physically lay cable throughout the entire country. So here in the United States, that took us between 5 and 8 years and we were relying on cable companies as well too, which were not necessarily the most technologically advanced, but to actually get the distribution mechanism in place. So if that was not a factor, imagine how, if the adoption of the internet went even quicker than it has right now, where we'd be at today. If you contrast that, then when you look at actual compute, we've all probably heard of Moore's Law, which was formulated by the co-founder of Intel, Gordon Moore, back in the 60s, where he was talking about, he's saying that the number of transistors, when he was talking about transistor compute technology, he says the number of transistors in a microchip would double approximately every 2 years. And that was accepted as Moore's Law, and we saw that kind of play out, and maybe it got a little bit fuzzy towards the end there. But today's version of that focuses on a different type of compute technology, which is GPUs, or the graphics processing units, which are what drive AI. And it's sort of the patriarch of GPUs these days is Jensen Huang, co-founder and CEO of NVIDIA. And he actually suggests that the performance of GPUs will double every 2 years. So it's particularly relevant if you really look at that in the context of parallel processing, increasing the demand for AI. So in short, it's the opposite of what we experienced with the internet. It's actually a force multiplier towards adoption and growth, and everything from training and capabilities. So it really is something that should be looked at as sort of an accelerant more than anything that could be throttling the growth and adoption of these models.
And the sense seems to be that we're on the cusp of another step change on that, isn't it? With NVIDIA are currently using their AI capabilities to design better and more capable and faster AI chips in order to develop better AI. And so there's this virtuous circle thing going on, which seems to have this sense of certainly acceleration, whether that turns out to be exponential. But it seems like that side of things is starting to happen quite quickly.
I mean, certainly we've seen compute being implicated in some of the most major advances we saw in that earlier slide about the history. For example, the defeat of Kasparov by Deep Blue was at least partly, it was a combination of sheer compute power plus some clever AI. The connection to the real world, I think, is really important. because at the moment we do have these rather disembodied large language models. And okay, they're starting to be able to be multimodal so that you can feed them images or perhaps even videos shortly. But the extent, I think a lot of the failings of them are actually attributable for the fact they're not actually learning in the real world as human children do. And so the extent that we can actually start to build AI systems in the future which do have a better connection to the real world, and that's not a 0-1 thing, it's there can be degrees of integration with the real world, will help make these AI systems have more common sense, more abilities, and also probably have better alignment to human values.
Yes, thank you, Tony. And Oliver, maybe I can just draw you in here for a moment as well. Chris, a while back, made a really interesting observation that ChatGPT has largely scraped the internet in terms of publicly available external data. And one of the main differentiators going forward is going to be an organization's internal data. From a data scientist perspective, how should boards be thinking about their internal data?
Well, there's two kind of main parts here, and it definitely leads on to from what Chris was saying earlier. You're right. There's the way I see it, data representation is going to be a key area that's going to unlock a lot of the capabilities in terms of differentiating and gaining a competitive advantage in terms of what the kind of suggestions that AI is going to be able to produce. In terms of data representation, there's a lot of kind of technologies and approaches that are probably maturing more now. There's all sorts of things people can do in terms of representing their data that shows relationships. We have vector databases and knowledge graphs that people are using a lot more, and they'll be able to interact with foundation models to kind of give you that kind of edge. But then something I like to think about in terms of mental models is, again, what's what we were talking about earlier in terms of encoding the heuristics and character. And again, that's kind of really critical in terms of fine-tuning the outputs that's more relevant for a particular organization, rather than giving these kind of generic outputs or overwhelming people with lots of solutions to a particular problem. But then another key area is data augmentation. And it's definitely something that a lot of teams have been using to a certain extent. But I think it's something that's going to be really huge going forward. And once you've kind of got these data structures that are really representing relationships between your data, you can imagine the kind of exponential growth in permutations, and you kind of got all these data structures of customer data. But when you kind of combine that with your context of the external world, your internal world, you can imagine how a single customer transaction could blow up into huge data structures in terms of what we understand about their customer, what are they going to do next. And a good example that I heard when everyone was talking about autonomous vehicles was an autonomous vehicle might see a pedestrian holding a pram, but if you can't see what's inside the pram, once you've kind of got that context to the wider world, you can create a probability of that there's probably a child in that pram. So I think that's quite relevant for organizations. And so that's definitely something people are going to have to prepare for, is how they're going to start representing quite qualitative data and turning it into something that's really useful and unique for particular organizations.
Thank you, Oliver. And Tamara, theory of mind, is it important?
Well, I might just kind of pick up on one other thing there, because what stood out to me from this around the curation side of things is what we know about the human brain and technology, through decades, is that there's a bi-directional relationship in terms of how one shapes the other. And given that our brains are highly, highly plastic, sort of speaking to the question earlier, I think we need to be aware of that. We can see in the use of smartphones and other technologies how they've begun to shape our brains. We see digital natives with different kinds of brain structures and connectivity. And this is, a million times more than that. Mm. And in terms of how these things are being coded and curated, it's sucking up all the biases of the people that are curating it. And from a equality and equity perspective, then we must be interested in who's doing that shaping. And the theory of mind question comes up a lot because it's linked to the alignment. Can we create a shared mental representation between the human and the AI system? What's potentially positive about that is it will force humans to be way more explicit about their intentions, which in my view can only be a good thing, because often we're not, and that's where we get into lots of trouble. But it's tricky, and I think if we're also kind of looking at the types of workforce that are spending time on these problems, if we did a study on it, I'm sure we could make a fairly reliable prediction that this might be a group where theory of mind scores were a little bit lower than the average population. Yeah, the people who like dealing with maths and numbers and codings. I'm making a massive generalization here, but as a rule, I would say this is probably true. Those are not necessarily individuals that are really great at theory of mind and social interactions. So, to have that conversation in a gentle and kind way, because it potentially has some huge impact.
Thank you. I just want to dwell on this point for a moment, even though we actually wanted to move on slightly faster than this, but I think it's an important point and it sets up a discussion later on. The ability to identify and address biases. And I want to draw in Chris and Tony here. One suggestion has been that you can't have just one foundation model, you need several in order to be trained in different ways, in order to remove biases. But do you have any practical suggestions in terms of, is that something that's going to be relatively straightforward to do? How might people start to think about that?
I mean, to remove all biases is probably impossible. I mean, all humans are biased in one way or another, even if they say they're not. So the most important thing is to actually know what the biases are. So if we know what the biases of the system are, then we can try to counteract with that. And of course, this whole theory of mind is very relevant to what we were talking about earlier, when we talk about artificial collective intelligence, is that these are going to be AI systems interacting with humans. And it's really important that those AI systems have some kind of theory of mind, so that they have a theory of what the humans know, which will then make them be able to interact in a more intelligent way, because they will know what the humans know and therefore can feed them information which they think the human doesn't know, and don't tell them what they think they do already know, for example.
But would you say that this issue of theory of mind and biases, does that influence the stepping on point in terms of, if people are just getting started, the direction of travel they go in?
I think yes is the answer. We need to be very careful about how we design the systems. And I think it's impossible to build an AI system and say, oh, we'll remove the bias from it later. That's not going to work. We have to think very hard about how we design our AI systems initially. And that ranges from this begin with just making sure the data is good and clean and unbiased as possible. And thinking about the kind of guardrails you might be putting in from the design stage, rather than just training on the whole of the internet and then thinking, oh dear, we've got a bias problem, what are we going to do about it? But it's sort of too late at that point.
Yeah, I think it's worth noting, as far as like where we at today. First of all, on theory of mind, anybody that's interested in kind of seeing what the capabilities are currently, when GPT-4 was released by OpenAI and Microsoft, they released a paper that was called Sparks of AGI. And a large portion of that paper is dedicated to what the capabilities as far as theory of mind are. And they essentially, you can see all the different tests, see what the results were of the test. Tamara and I actually went through some of our own tests, actually. And it's basically at, below adolescent level of theory of mind, if you're comparing it to humans. So, above child, but not full, adult level. So there is some degree of it that's available, that is currently available within these models. So that just kind of a fascinating, interesting thing about where we could go with this. And then, certainly when it comes to bias, just understanding that there are ways to influence the bias within the models. The biggest one is reinforcement learning, which is actually why ChatGPT was even released in the first place. It was made free so that humans could interact with the answers that they were getting from the model. And if you've ever noticed those little thumbs up, thumbs down, that's why it was free for so long for everyone. Because if you see a wrong answer or something that's inappropriate, they were encouraging you to thumbs down, and then a window pops up and you actually type in what was wrong with it, or harmful or incorrect, and then that goes back into the training. So that has been happening since GPT-3, and so GPT-4 has a lot of that human reinforcement in there. Currently, that's just one of the tactics available to actually influence bias. And the other part, of course, is training, just to kind of frame up training the models like OpenAI and Microsoft are doing and Google's doing, there are very few organizations that actually have the compute and the budgets to be able to do that. But within the organizational level, you can do things like fine tuning, or even retrieval mechanisms where you're actually pulling in your own data to influence and create essentially your own bias, not negative bias, but like what really impose your organization's thought process and heuristics on the model outputs themselves. So all those are all very possible today in one degree or another. So you should know that there are tools available to be able to influence that within the corporate deployments.
And there was the paper as well that showed that accuracy improved when you asked it to show its workings. And again, from a psychological perspective, I love that, of course, because it's like, let's examine how you got there. And then we can dive a little bit deeper into the mechanisms and the logic or the thinking skill.